Good day, everybody. So today we are looking at the question under bearing and distance. And the question happens to be NEC Code 2025, question number 9A. So let's read what the question says. Say an aircraft took off from an airstrip with an average speed of 35 kilometers per hour on a bearing of 015 degrees for 2 hours. It then changed course and flew on a bearing of 100 degrees with an average speed of 22 kilometers per hour for another 2.5 hours. Find the distance from the starting point to 2 decimal place. So before you can solve a question on bearing thoroughly, it's very important you draw the diagram for the description and also calculate the distance if the speed and time is given to you. So let's start. From physics, we are told that speed is defined as the rate of change of distance with respect to time. So with that definition, we can conclude by saying, you can say now that speed is simply distance, over time. That's the definition of speed. So for the first distance, say the aircraft flew for 35 kilometers per hour, which is the speed, and it did that for 2 hours. So let's find the first distance. So in place of the speed, I'm having 35. Is equals to, let's call the first distance as d1. The time used to do so is 2. So if I cross multiply, my d1 will simply give me 35 times of 2. d1 is simply 70 kilometers. Then if you also go, say the second distance, it travels for 22 kilometers per hour for 2.5 hours. So let's find the second distance now. That becomes our d2. So my d2 is simply also speed this time times time. That's our d2. So from here, I made this line the subject formula, it becomes speed times time. So my d2 will give us 22, which is the speed, times 2.5. So this can be written as 22 times 5/2 as our distance. This can cancel this. So my d2 second distance is simply 55 kilometers. So with the two distances known now, I can now draw the diagram for the motion. Let's draw a diagram for the motion. So the first distance is now 70 kilometers per hour for 015 degrees. So let's draw the motion for this diagram. So at this point, first body, if aircraft first flew, so let's take here as our first point now. This is the airstrip. Let's take here as our airstrip. Let's take this point as our airstrip. This is now the airstrip. Let's call it A. Let's call the airstrip A. So under it, here is my node, which is 0. So we all know by definition, bearing is the angular distance between 2 points in a clockwise direction from the node. So from the node, that's why I will trace my bearing from this node. And the first bearing given to us from the question is 015 degrees. So let's trace 015. So every quadrant is 90. So the whole of this point is 90. So 015 will be, let's assume from somewhere, from here to here. Please note, this diagram is not drawn to scale. So from here I have 015, and the distance used to do so is simply 70 kilometers per hour. So at this point, I have another quadrant there. Okay, so here is now 015 degrees. which is distance travel now is 70 kilometer. So second bearing is now 110. This time around, what we calculated the distance was 55 kilometers. So how do we draw this? Please pause the video and draw the diagram and post it on the comment section. How do we trace 100 degree bearing from the second quadrant? So to trace 100 degree bearing, so at this point, here is also my north, which is 0. From here to this quadrant is 90. So 100 should fall under the second quadrant. So I will move from here, which is 0. If I trace to this point, that becomes my 90. So let's assume somewhere here as our 100. Like I said, the diagram is not drawn to scale. So at this point now, I will have my distance of 55 kilometers. So let's take somewhere from here to here as our 55. 70 is longer than 55. So here I will have my third quadrant. So let's take this point here as B. Let's take this point here as C. So the whole of this bearing now is 100 degrees. So what's now this value here? So the whole of this place is a straight line. These two angles are supplementary. Means that some will give us 180 degrees. That means here will be 80 degrees. So this distance is 55 kilometers. So if here is 80, here is equally 80. Reason for that is alternate angles. Here and here they are alternate angles. The same is also true. If here is 15, here is also 15 degrees. Reason for that is also alternate angles, which are equal. So what is now the total angle at B? Is simply 95 degrees. That's the total angle at B. So to complete the motion, I will join from point A to point C. So let's join A to C to complete the diagram. This is now A to C. So question Roman figure 1 say we should find the distance from the starting point to two decimal places. So if you should go back to the diagram, you can see that the aircraft is now at this point. The aircraft is now at this point. What is the distance from the starting point? So how do we solve this distance? Please, you can also put that on the comment section. There are two ways of doing so. Option A, cosine rule. Option B, sine rule. Or option C, Pythagoras theorem. Which of them can we use to solve the distance between A and C? Pause and put the answer on the comment section. So let's continue. To solve point A and C, we are going to use cosine rule because we have two distance and an exclusive angle between the two distance. And the angle is more than 90. If it's more than 90 or less than 90, we are going to use cosine rule. So according to cosine rule, if here is capital B, the opposite side is a small b. Capital C, small c, capital A, small c. So if you go by that, we are looking for our small b. So let's find our small b. So that would be Roman figure 1. So our Roman figure 1, I'm going to have small b squared equals to a squared plus c squared minus 2ac cos big B. So what is, we're looking for small b, which represent A to C. So what's the value of small a? Small a is the opposite side, which is 55. So my b squared will be, so my small a now, which is 55 squared plus small c, which is the value of 70 squared minus 2 times a again, 55 times 70 times cos 95 degrees. So we're going to simplify what we have here. So by using our calculator, what's the value of 55 squared? So b squared will give us, so if you square 55, it will give you 3025. If you square 70, you have 4,900. If you multiply 2 times 55 times 70, will give you 7700. Cos 95 will give us minus 0.0872. 95 fall under the second quadrant, and cos under the second quadrant is negative. So that's why we're having a negative value as cos 95. So if we add up, if we add these two up, then use this to multiply this minus, I'm going to have a positive sign. Here it becomes positive because here is negative, here is negative. So let's see what that gives to us. So I'm going to have b squared is equals to, so if we multiply this by this, we are going to have 671.1. So we can add everything up. Let's see what we have. So our b squared will give us 8596.1. So b squared is simply my AC squared, which is 8596.1. So my AC becomes what? Square root of 8596.1. AC is equals to what? So let's see what AC gives to us. Our AC will give us 92 point, 2 decimal place, 72 kilometers. That's the distance from the airplane or the aircraft from its starting. So that's not the distance of the aircraft from its starting point. So let's go to Roman figure 2 of the same question. Roman figure 2 says we should find the bearing of the airstrip, the bearing from the airstrip, find the bearing from the airstrip to the nearest degree. So go back to our original diagram, the bearing from the airstrip to the nearest degree. So this is the airstrip. Where's the bearing? Like I said earlier, the bearing comes from the north in the clockwise direction. So I'm going to use a different plane to indicate it. That means start from here to here. So the bearing of the aircraft from the airstrip is simply this angle and this small angle we have here. But the question is, what's the value of this small angle? We don't know it. So let's call this small angle here, let's call it theta. So we have to look for theta in order to find the bearing from the airstrip. So how do we do that? We are going to apply sine rule. So Roman figure 2, we are going to have this at the angle theta is at A. So we consider A, then we consider B also. We have B on the opposite side. So I'm going to have small a over sine big A is equals to small b over sine big B. So what's the value of small a? And small a remains as 55 kilometers. So I'm going to have here 55 over sine theta is equals to small b, already we've calculated that already, which is our AC, is 92.72 over sine 95 degrees. From here I can now look for sine theta. So sine theta will give us 55 sine 95 over 92.72. That's not the value of sine theta. So let's find, multiply and divide. Let's see what we have from there. So if you multiply and divide, sine theta will give us 0.5909. So theta now becomes the sine inverse of 0.5909, and that will give us 36 degrees. So let's go back. What's the bearing now from the airstrip? So you know, from this point to this point is 15, and here is now 36 degrees. So the bearing must come from the north to the line joining where the aircraft is to the airstrip. So which is now from here to here. That would be 15 and this angle 36. So the bearing is simply 15 plus 36. That will give us 51 degrees. But I'm adding 0 because it still falls under the fixed quadrant. So thank you for watching. If you like what you're watching, please subscribe, comment, and share. See you in our next class.